Bismillahirrahmanirrahim. Today we will be talking about filters, the electronic filters, you can take frequency filters. As what is meant by a filter? Filter is something that allows a desirable thing or the thing that we want to be extracted from the thing that we do not want, or you can say that it extracts out the useful thing from the and rejects what is not useful or what is not required by us. So likewise, there is a water filter. Water filter just separates out the bad components of disease or the microorganisms or dust particles and filters out the water from it. So what is required in that scenario is water, and what is not required is that dust particle or bacteria. Likewise, in electrical electronics, we have frequency filters. Now, why frequency filters are necessary? Frequency filter, there are different types of frequency filters. For example, there are active filters, passive filters. Where there are two types of filters, active filters and passive filters. What are active filters? Active filters are those that involve the active components, and what are passive filters? And it's also that involve the passive components, like that can be made because of resistor, capacitor and inductors combination. And these were the passive. And active components or active filters can be made from transistors or amplifiers types of thing. So we would be talking about the passive filters, and there are two main type of filters: the high pass filter and the low pass filter. Now, what is high pass? What is meant by high pass or low pass filter? High pass means the type of filter that allows the high frequencies to pass and low frequencies, high frequencies to pass from it and the low frequencies to rejects out, or that only gives the output when the frequency is high. And the low pass filter are those that only gives the output when the frequency is low. So these can be made by the combination of resistors, capacitor, and inductor. So there are there are basically two types. The high pass filter can be made of inductor resistor combination and inductor capacitor combination. Likewise, low pass filter can also be made by inductor resistor combination and capacitor resistor combination. So let's talk about any one of them. Let's say high pass filter. Now first of all, let's make a circuit diagram. Here is a resistor, and in series is a capacitor, and it is connected to the input. Now we are taking output across the capacitor. So we have to apply the input right here, and we are getting an output right here. Now as we know that where the voltage that is applied across here is basically dividing between these two components. Now as we know that capacitor is a component whose resistance or whose you can say that reactance increases with the decrease in frequency. You can say that when the frequency is zero means when the input is DC. Input is DC means the capacitor is open, and capacitor is open means it has the maximum resistance. So according to the voltage divider rule, C over R plus C, here C means XC, basically XC means reactance. So as this component is too much higher, so the output will be maximum. Similarly, but when the frequencies increases, its open behaviors start getting reduced, and so the XC components become smaller and smaller with the increase in frequency. And when it becomes small, the numerator becomes small and denominator become large. So at higher frequency the output will be low, because according to the voltage divider rule, XC will be small and the sum would be the same, so R would be large. So the maximum drop will be across the resistor and the minimum will be across the capacitor in case of high frequency. And in case of low frequency, if the low frequency, or you can say that no frequency means DC. If DC is applied, then capacitor is open means all the voltage that is applied in the input is going on the output across C. So this is the main idea. Likewise, then this is the low pass filter. So if the same thing, now likewise, let's make a high pass filter with the same combination, that is RC combination. So what will be thing that the same series resistance component application of voltage is the same, but we are getting the output across resistor now. So the same phenomena that was in the low pass filter, that when the frequency is low means we are starting with DC means zero frequency. When the frequency is too low, then capacitor is open means all the voltage is dropped across here, all the voltage is dropped here, voltage is dropped here, and no voltage is going there. It means that at no voltage is dropped here, so on DC we are getting zero output. Similarly, but when the frequency is increased, the its reactance becomes smaller and smaller, because we know that XC is equal to 1 over J omega C. So it means that when the capacitance is high, the reactance will be low, and when the reactance is low, it means that the output will that the drop would be low here and high here. So it will become a high pass filter, because जब इसके जो फ्रीक्वेंसी है वो हाई होगी तो यहाँ पे ड्रॉप कम होगा, यहाँ पे ड्रॉप ज़्यादा होगा, और जब फ्रीक्वेंसी कम होगी तो यहाँ पे ड्रॉप ज़्यादा होगा, यहाँ पे ड्रॉप ज़्यादा होगा, यहाँ पे कम होगा, और जब फ्रीक्वेंसी ज़्यादा होगी तो यहाँ पे कम होगा और यहाँ पे ज़्यादा होगा. So it is high pass filter. Same thing can be done with RL filters. Just replace that capacitor with an inductor. Let's say just replace it with an inductor. Then what will happen now, that we know that inductor has the opposite behavior. When the frequency is low, the inductor is short. Inductor is short means no voltage will be dropped here and maximum voltage will be dropped. So as we know that XL is directly proportional to, or you can say that XL, the reactance of inductor, is equal to SL or J omega L. It means the increase. So it means that when the frequency is increased, the resistance is increased. So it will become a low pass filter. Likewise, it has the same phenomena here. You can read about it on the internet. Now the second thing that we would be talking about is the cutoff frequency. What is cutoff frequency? So what is meant by the cutoff frequency? Cutoff frequency basically means that the frequency on which the power output power become half of the input power, or you can say that on which the gain is 0.5. 0.5 gain means the ratio of output to the input is equal to 0.5. It definitely means that output is half of the input. But this in case of voltage, it becomes 0.707. When the output is 0.707 of input voltage, then the on that frequency is called the cutoff frequency. So the unit was introduced by a scientist. As we know that the gain is either very large or very small. So for that purpose, the logarithmic scale was introduced, so that we can get a whole number value of the ratioed answer. So the formula of decibels becomes 10 log V out over V in. So this is what that would be the gain in the decibels, represented by a V. Let's say in case of V naught, it's 20, and the proof would be easily available. So this is the thing. So let's see this behavior on the PSpice now. I have made that circuit on the PSpice. The same that the resistance is connected with a capacitor RC filter, and we are taking an output on C. It means it should have to be high pass filter, sorry, low pass filter. So let's see its outputs now. Now, as described before, so what was it? That on the low frequency we would be getting an output, but as the frequency is increased, you can say that the gain is decreasing, and up till 0 or near to 0. So जैसे जैसे फ्रीक्वेंसी बढ़ती जा रही है, आउटपुट जो है हमारी या गेन जो है वो कम होती जा रही है. सो कट ऑफ फ्रीक्वेंसी के ऊपर जो हमारे पास गेन होती है डेसिबल्स के अंदर, वो आ जाती है -3 डेसिबल्स. सो एक नई डेफिनेशन भी हम बना सकते हैं कट ऑफ फ्रीक्वेंसी की, कि द फ्रीक्वेंसी ऑन विच the gain of the on which the gain is -3 decibels is called cutoff frequency. So it is cutoff frequency, or this the thing that you are seeing here, the graphs, this combinedly is called Bode plot. Bode plot sometimes only the when the magnitude is constant is called Bode plot. So separately it is the phase plot, and the phase plot is dealing about the phase shift that is between the input and the output. So that was all about the filters of the office.